Why do polymers break due to viscoelasticity? Have you ever wondered why some plastic items seem to lose their strength over time? The answer lies in a fascinating property of materials known as viscoelasticity. So, why do polymers break due to this property? Let's break it down. Polymers are unique materials made up of long-chain molecules. When you apply stress to a polymer, it reacts in two ways. First, it behaves like an elastic solid, which means it deforms immediately and can return to its original shape. This is the elastic response. However, there is a second response that is equally important. This is the viscous response, where the polymer continues to deform over time. This gradual deformation is known as creep. When a polymer is under constant stress, it can start to show signs of damage. If the stress is too high or lasts too long, the molecular chains can slip, break bonds, or rearrange themselves. This process happens at a microscopic level, but the effects can be significant. Over time, these small damages accumulate, leading to a weakened material that may eventually fail. The balance between the elastic and viscous behaviors is key to understanding viscoelasticity. The elastic component comes from strong covalent bonds that act like springs, while the viscous component is influenced by weaker bonds, such as hydrogen bonds. When the load is too great or applied for an extended period, the polymer can suffer permanent damage. Temperature and the rate of loading also play a role in this process. When stress is applied quickly, the polymer may seem stronger because the viscous component does not have time to react. However, at slower rates or higher temperatures, creep becomes more pronounced, increasing the likelihood of failure. In practical terms, this means that everyday items made from polymers, like pipes or structural components, can slowly deform under long-term loads. Even if the stress is below the immediate yield strength, the material can still fail over time. Designers and engineers must consider these factors when creating products from polymers. Understanding viscoelasticity helps predict how long a product will last and how it will behave under different conditions. This knowledge is essential for preventing mechanical breakdowns and ensuring safety in various applications. So, the next time you see a plastic item that seems to have lost its strength, remember that viscoelasticity is at play. The combination of elastic and viscous responses leads to time-dependent deformation, which can ultimately result in failure.